on numbers. The first concept is coming today is it says the any for any natural number, for any natural number n, the square of n plus 1 whole square, n plus 1 and n, there will be two n numbers of non-square natural number. So that means if I take the value of n plus 1 whole square and n square, so if I can put them in the number line, let's say this is n square and this is n plus 1 square. So in between this I will get 2n numbers, 2n number, the different number 2n which will be counted as 2n, that much number will be non-square, that means not a perfect square. That means leaving n square and n plus 1 in between. That means this number's range would be, this 2n number range will be in between n square and n plus 1 square, not equal of this, not equal of this. That has to be proved, and that is a concept, you can say, that is a theorem, you can say. So how will I prove that? So simply, if I do the subtraction of the number n plus 1 square minus n square, now if I do that, if I take that example again, now this is n plus 1 whole square, now, and this is n square. Now if I deduct n plus 1 whole square minus n square, this will include this also, because if I say 3 square minus 2 square, so this will include 2 square together, not leaving 2 square. So 3 square minus 2 square, the result will be 5. So that means I am including 2 on the calculation, but my range says it should not touch even n square. So then if it is the case, then what I have to do, I have to minus 1 further from this, so that this count, this is count, this is not the not a particular number, this is the count, because n plus 1 square will be a natural number, it will be a natural number. That means between two consecutive number there is a difference of 1. So this will give you a count, because I am not leaving any number in between. So if I say this is representing some number, let's say this example again, 9, that means 1 to 9 every number minus 1 to 4 every number, that will give you the 5, that is the count in between 9 and 4. That way I am saying. So this will give you a count of number. So if I expand it, it will give you 2n plus 1 minus n minus n square minus 1. So that means this will be cancelled out, n square will be cancelled out. So the remaining is 2n. So this 2n is the number of the count of the number in between these two, which will be a non-perfect, non-square, because you can see these are the consecutive square numbers. N plus 1 and n square are consecutive square. In between there should not be any square. So if I deduct this number, the count which will I get, it will definitely be a non-square, means non-perfect square. Okay, understood? Because these are the consecutive, because between these terms there is a gap of 1. So if I square it up, this is the consecutive terms which is comes as a square. So that means if I take 2 that means 2 plus 1 3 and 2 for example. So this will give you 3 square minus 2 square, that means 5. So in between there should not be any natural number whose square can be included. So if I take this difference, I will get 5 numbers of such which is lying in between 9 and 4, which are non-perfect, is not a perfect square. Understood? So theory says any two consecutive numbers where n is the natural number will lie to n numbers of non-perfect square. Okay. Next, moving to the next theorem, which says, which is a concept again, it says if P and Q are natural numbers, then P square is equal to 2Q square. This relation cannot be possible. Cannot be possible. This you have to prove. So this needs a proof that if P and Q are natural numbers, then P square is equal to 2Q. This relation can never exist, cannot be possible, can never exist. So what are the different conditions? Because P and Q are the natural number set, so there could be 4 conditions which may arise where P and Q are both odd numbers, because this even and odd lies between the natural number. I have said this P and Q are natural number, so obviously it could happen that P and Q in some cases, if it is odd, then what would happen? Because if I take this condition, now naturally P square and Q square will also be odd numbers too, because I have already told any odd number square is an odd, and any even number square is also an even. So if I square of any odd number, the result will give you an odd number, and any even number if I square up, it will give an even number. So from that concept, if P and Q are both odd, the first condition is that the case 1, you can say case 1 where P and Q are both odd, so P square and Q square will also be odd. Now if these are odd, so what is 2Q square? Because multiplying any number with 2 will give you even number. So if you see in the equation on the right hand side, this is right hand side, and which tells 2 into Q square would be even for any number here, because this is a factor which is coming 2, so this is an even number. Whereas P square is now when it is a odd number, because P is odd, P square is odd, so any even number cannot be a odd number, it cannot be equalized. So hence we can say for the first condition P square is equal to 2 square, not possible. Okay, so this thing is understood. The case 2, if any of this is anything, means I am taking second condition, P is odd and Q is even, then what will happen. Now P is odd means P square is odd and Q square is even. So again that implies that 2Q square also even. Okay, so 2Q square also will be even. So here also the same condition coming. So P square is equal to 2Q square, odd and even cannot be same. So it implies P square cannot be equal to 2Q square. Okay, for this condition. Now this is case 2. Okay, now coming to case 3. In case 2 I have explained, if P is odd, Q is even. In case 3 I'll make it opposite, where P is even and Q is odd. Then in that case P square is even. Now I can assume that P, as it is even, it can be represented at any number, any natural number m again, with multiplication of 2, because 2 will be definitely a factor as it is even. So m is a natural number. M is a natural number. So this will represent P. And now if I put the value here in the equation, the P square become 4m square. Okay. Now if I let this P square is equal to 2Q square. Now if I put the value of P, this will become 4m square is equal to 2Q square. Now if I cancel it out, this will give you an expression where it will become 2Q square is equal to 2m square. Now m belongs to a natural number again, and P and Q all are natural number, but in case that Q has been taken as odd, so this will be odd, and as because it is multiplication of 2, this total will be an even. Now this condition cannot satisfy, as because odd cannot be even, so this also nullifies. So you can say if this nullifies, this is a part of that equation from that I have derived. So you can say that P square is equal to 2Q square also does not implies. Okay, so this is the third condition. Now come to the fourth condition, where P and Q both are even. Both are even. Now in this case, if both are even, so one thing is that both have 2 as a factor, definitely, and if I, as because they both are even, there is a chance of a common factor other than 2. Let's say that highest common factor for P and Q is equal to D. So definitely P can be represented a multiplication of D and any other natural number, and Q also can be represented Q in D into any natural number, where we can assume M and N belongs to natural number again, and D are their HCF, highest common factor. So if I go further, then this equation can be written as D square M square is equal to 2D square N square. So D can be cancelled out. M square is equal to 2 into n square. Okay, now as I have taken out d, means d into m, and here d into n. So if I take out d, means if I divide this number with d, both the numbers, then this m and n will only have one common factor, that is equal to 1, because I have taken the highest common factor. After that there will be a no common factor other than 1 will remain. So I can say that if this is the case, then m and n will be a natural number, and this can be any number. That means that can be even, that can be that cannot be even, because if even is there, 2 also be added to the d. So these are some natural number. One of it certainly be a odd number, and other could be a even number, because this m and n only have one factor. So this is possible only when m or n in between these two, any of these a odd number. Okay, now if any of this an odd number, then the previous three condition will already have discussed, and that will fall on that case only. Because if I say m is odd, then odd square is equal to even, not possible. If I take m is even, n is odd, then also the case 2 will follow, and also I have that proved that it is not possible. For any case, now I can conclude that m and n only have one common factor, that is equal to 1. And if it is so, m and n can either be a odd number. So then the case 2 and 3 that which I have explained earlier, that will fall on that, and on that case I have already explained that the equation is not possible. So from that case 2 and case 1 and 2 this is case 4, sorry. So case 2 and 3 I can conclude that this p square is equal to q square, 2q square is not possible, even both are even. Okay, understood. So this is one theory, a complete theory, where I can say for any natural number p and q, p square is equal to 2q square is not possible. So this is up to now. In next video I will tell you more on these theories, very useful theories and very interesting too. Thank you. Good night.